Good afternoon to you. Mark Sutton with HurricaneTrack.com here with your hurricane outlook and discussion for Friday, the 3rd of August, 2018. Hopefully the audio is much better today. It wasn't too good yesterday, so I think I fixed it. I haven't fixed the Atlantic Basin in terms of not producing hurricanes. It's still not producing hurricanes, and I would guess for most people that is great news. There are a couple of areas out there that are kind of interesting. This is the most convection that we have seen off the coast of Africa along the intertropical convergence zone. That's right about 10 degrees north latitude there. That's about as much as we have seen in quite some time, so maybe things are slowly swinging towards becoming more favorable, generally speaking. Basically, we just have a tremendous amount of subsidence out here, sinking air. That's air that is, it's moving downward in the atmosphere, subsidence, and that doesn't allow for upward motion. Makes sense, right? And so in the lack of that, we're just not seeing any organized areas of deep thunderstorm activity. This is associated with an upper level low pressure area in the atmosphere, cold air spinning aloft, and you have that very warm ocean temperatures underneath here, and so that's leading to some rather stormy conditions in parts of western Cuba, parts of the Florida Straits, maybe the Cayman Islands. I was trying to remember which islands were over there, so forgive me. So the Atlantic Basin, really, really quiet, and it looks like it's going to stay that way for quite some time to come. So let's take a look at Hurricane Hector now in the Pacific. This is on its way to eventually becoming a major hurricane. It weakened a little bit recently, and you can see the track there suggested over the next several days that this will potentially impact Hawaii with at least some increase in wave activity, and maybe even more than that. This is 5 days out, so you never know, but as this approaches, you'll definitely get some of that swell coming out ahead of Hector, and the southeast facing beaches are going to have a much larger surf to deal with. So I guess that could be positive for the surfers, but negative for people that don't want such large waves. So we'll keep an eye on this. The general thought process, if you want to call it that, even though the models don't technically think, these are not HAL 9000 computers, at least not yet, but the general thought process, overall prognosis, that's what I should say, from the model, the ensembles, etc., is that Hector will bend back to the north a little bit, but it should stay south of the islands. It should. Now, this is more than a week out, so you never know for sure, and we'll be keeping an eye on this very closely, as you can imagine. So looking at the satellite animation, now this is on the western edge of the peripheral vision, if you will, of the GOES-16 satellite, way out there in orbit, geosynchronous orbit. And so it's not quite as clear, it's a little pixelated, but nevertheless a fine floater image, and in this case a series of images from Levi Cowan that he has put together. Remarkable job he has done at Tropical Tidbits to provide us with these floaters, since they are absent from the Hurricane Center site, since we lost the GOES-13, so to speak. It's not gone, it's just out of commission in deference to the GOES-16 imager. And so we get these floater images from private sources, if you will. So that's kind of, it's interesting how that works. But you see it's fairly well developed. Classic hurricane, got the eye right there in the middle of the deep convection. And then you have some deep moisture trying to feed into it out of the intertropical convergence zone, and you can bet that down here the water temperatures are higher and the overall moisture content of the atmosphere also higher, and so Hector should continue to move along and intensify over the next several days. So what does the future of Hector look like? As I was alluding to, the modeling generally suggesting that it'll stay south of Hawaii. So let me point out what's what. There's a couple of interesting things here. First, let me just show you the geography real quick, and I'll leave this up for a minute or two while I point a few other things out. So that's the west coast of California there, the Baja, and then down into Mexico, and there's the west coast of South America. And just to fill in some things, there's Texas, around the Gulf of Mexico, and the eastern side of Central America. There are the Hawaiian Islands right there, and then Japan is way over here on the west side, okay? And this guy right here is Hector. And then look down here. This is interesting. Notice how these wind barbs are facing this way. They're going from west to east, and then over here they come generally east to west, and then you overall have this sort of swirling going on. In other words, a large cyclonic gyre. Okay, there it is. It has set up this monsoon trough type pattern in the eastern Pacific, and that's going to spawn quite a few active cyclones over the next several days. And if we put this into motion, speed it up a little bit, and you can see how this evolves. We'll run this through a couple of times. So there's Hector right there. There's Hawaii. That's the big island. And so watch how Hector, that black cluster of circles, very tightly packed in there, showing that it's a very well-developed system in the 850 millibar field, which is what we're looking at here. This is about 5,000 feet in the atmosphere, and we're looking at relative vorticity, spin in the atmosphere, energy, and the compact, rounded nature to this system shows that it's, intense. A tropical cyclone, that's what it is. So it moves south of the islands as this area of high pressure out over the central Pacific stays pretty stout, and there's really nothing to impinge on it or jackhammer it away enough, at least in this run of the model. Now, don't let that fool you. It can change over time. I still definitely have my eyes on Hector, because any deviation, especially if it were to turn later like this and then continue west, it's just I'm just hypothesizing here. That would be something I would be pretty concerned with in terms of direct impacts. It is very, very hard to bring a hurricane into Hawaii from the east. I saw Josh Morgerman tweeting about that a lot yesterday. It's just very hard to do. It does Hawaii, the volcanic nature to its high mountain peaks. The volcano part doesn't have anything to do with it, but those are volcanic mountain peaks related to the geology out there in the Pacific. And over eons, you've got these tall peaks that have developed, and they do weird things like really sticking a heck of a knife into, a living thing, and it kills it. I mean, you see these hurricanes approach Hawaii from the east, and they just get the guts ripped out of them. And Niki came from the south in 1992, and so that had a different trajectory. Meantime, you see over the course of the next 7 days, these two systems try to develop, one of them fairly close to the Mexican coast, relatively speaking, closer than we have seen lately, and then they start to try to interact with each other up here by day 7, so that's going to be interesting. We'll have to see if there's any potential of sort of shedding off of this moisture down here, getting pulled into the desert southwest, enhancing some of the monsoonal action. Maybe. I'll be keeping an eye on that. I'm still itching to get out there and witness some of that. That big haboob yesterday, again, in Phoenix. I want to see that in person, not only just from a fascinating, point of view, like, wow, that would be amazing to see, but, gosh, if I could just get some of my equipment out there, especially if I knew there was a pretty good chance of convective activity, it'd be great to mount a weather station in front of that thing and capture wind data. And this is hard to do, and this is part of what I'm trying to grow on my Patreon page, or not just the page, but the whole idea of funding this in the future, studying the monsoon. It's more than just going out and taking pictures and video. I want to actually study it, and hoping to get that chance. We'll see how the rest of August goes. I think the Atlantic Basin being quiet could maybe provide me with that opportunity, because it's not going to stay quiet for the whole season, I assure you. So look, I want to show you this before I wrap things up for the weekend. I'll be around over the weekend, but this is the Friday edition, so wrapping it up before the weekend gets here, I guess. Gulf of Mexico sea surface temperatures, I show this often. Very warm at the surface here, 30 degrees Celsius. Eastern Gulf has cooled down just a little bit because of the shower and thunderstorm activity, cloud cover. and just the general agitation that provides, like stirring around in a bathtub or whatever, mixes up the water a little bit. But it's still very, very warm, 28, 29, 30 Celsius, very, very prevalent across the Gulf. And the same can be said here, generally speaking, for the areas in the West Atlantic. Let's change this to the color white so it shows up better. Very prominent Gulf Stream right up through here, 26 degrees Celsius isotherm, getting a little bit farther to the north. Oh, I almost messed up there. It is farther. Farther to the north. And so you look at these and you go, wow, water temperatures are very warm. And so how warm are they? And this is what I like to keep an eye on. Once we get into August, more so than anomalies, those are still important. But to me, this becomes the most important aspect after you look at where the 26 degrees Celsius isotherm is. Why is that important? Well, 26 Celsius, we roughly call that 80 degrees. Just round it up and call it 80 degrees Fahrenheit. And that is typically, under normal circumstances, the ocean surface temperature that you have to sustain tropical cyclone development at all. Now, yeah, sometimes you can have colder sea surface temperatures, 24, 25 Celsius, but your atmosphere above the storm is so much colder that the relative difference creates massive instability, and you can get tropical cyclone activity way up in the North Atlantic, even in the wintertime or the spring, April or whatever. And we had that one January hurricane, right? Remember that? Last year, wasn't it? Alex? I mean, how quickly? I forgot. And those are different. Those are anomalies. Those are, outliers when you look at statistics. So 26 Celsius is considered the threshold. Fine. Okay. Now, how deep in the ocean does that 26 degree isotherm go? How deep is that 80 degree water? And that's what we look at when we talk about upper ocean heat content over here. And the higher up on the scale you are, the more upper ocean heat content is available. And of course, that usually resides right here in the western part of the Atlantic basin. But it is also prevalent in other areas, okay? And there's just a little bit. It's starting to show up at the bottom of the scale, all throughout the deep tropics here and then up into the subtropics. Very prevalent off the southeast coast and quite prevalent, in the Gulf of Mexico. All right, so it's definitely there. Like we talked about, the stage is set. But I wanted to show you something. What is the difference? Why aren't we getting anything developing this year so far after we had Beryl, down here in the deep tropics in early July? Then we had Chris that formed out here, and it took off to the northeast, and that has been it. So we do have strong tropical waves, and African jet that's putting these systems out into the Atlantic, no doubt about it. In addition to the subsidence that we have, this sinking air that's out here, very prevalent. You don't see that on this picture, but that's where it is. It is different, all right, than last year. And I just wanted to show you. And this is the beautiful thing about data. This is what the upper ocean heat content looked like 1 year ago, okay? So, I mean, come on. It is vastly different, especially out here in the tropical Atlantic, the open tropical Atlantic. There was a lot more heat content. Even though it was on the lower end of the scale, it was still there, and it was much farther to the north. That 26 Celsius isotherm was in early August, and so it's not just the warm water being there. That warm water sitting there day after day after day, and the Atlantic was very warm early last year. It just gives off tremendous amounts of heat content into the atmosphere, moisture, what we call latent heat in the lower portion of the atmosphere, usually below about the 700 millibar level or so. And that humidity, that moisture content, it'll get scoured out and mixed by Saharan air intrusions, and that, of course, has been very prevalent this year. That's another negative factor. But last year, this was definitely a big part of it. All this heat content that was already in place, just adding to the overall background moist environment. Plus, the Saharan air outbreaks weren't as prevalent last year. But I wanted to show you this just to compare. It is a different type of season. However, and we'll wait until we get to, and I'm going to do this later, when we get into September, the end of August into September, when Irma and then Maria formed, I do want to compare these charts here, because this is the area, remember Irma formed way out here. I want to compare what did it look like last year versus this year once we get another month down the road. All right, because you'll see that I think there's still enough energy for strong hurricanes, but we have other things going on that could inhibit them until they get more west in the basin. And I know that's a little confusing, but I keep hearing how cold the Atlantic is, and it's not cold. It's not 55 degrees, and it certainly isn't cold over here. And these are the areas where Irma and Maria had the biggest impacts, as you, of course, remember. And Jose, too. All right, so when we get later down the road and this catches up, it's not fair to compare, August 2nd. These are always a day behind, and sometimes longer. You can't compare August 2nd to August 30th, which is roughly when Irma got its start. So on August 30th, we're going to go back and look, and we'll see what it looked like then versus what it looks like this year, and we try to play sort of an all things considered, all things being equal game. Would Irma be as strong this year as it was last year? If everything else was the same except the sea surface temperatures variable, and we can try to guesstimate, gives us something to do while we're seeing if something develops. At least I think that's interesting, because so much talk about how cold the water is, yet I still think it's warm enough to support intense hurricanes. It's the other factors that have to be overcome, and when they do, I still think we will see a big burst of activity, probably at the end of August through September, and that's when it naturally is supposed to happen. No surprises there. All right, so there you go. You're caught up for today. Hopefully the audio is much better, and you guys have a good weekend. I'll be around tomorrow and Sunday for an update in the afternoons probably, and we'll keep track of what's happening with Hector. Hey, listen, if you have plans to go to Hawaii, don't cancel them. Don't even worry about it, because even a direct hit, like I said, I'm going to just emphasize this one more time, it's really hard to hit the Big Island especially. You think about where Hilo is and the resorts there. We'll watch Hector, but don't worry about it too much, okay? Seriously. I am Mark Sudduth, HurricaneTrack.com. Thanks as always for tuning in, and I will chat with you more over the weekend as we progress through the next couple of days.